All right, here goes. Perimeter and area. These may be terms that you're pretty comfortable with, and if so, that's fantastic. But a little review doesn't hurt, and if you haven't seen them before, let's make sure we know what perimeter and area are talking about. The perimeter is the distance around a figure. So it doesn't necessarily have to be a rectangle, but if we imagine that it's a rectangle, it's the distance around the figure. Meaning if I were to stand right here in this corner and walk all the way around the figure, how far would I go? That's the perimeter, the distance around a figure. When you think perimeter, something you can think about is like a fence. How much fence would there be? And if we measured the fence, we would see something that might be in inches or feet or yards or centimeters or meters, probably not inches, but those would be the types of units we would be looking at. Inches, feet, yards, centimeters, meters for a fence and for perimeter. Area is a little bit different than that. Instead of the distance around a figure, it's the amount of surface that the figure covers. So we can stick with the rectangle here and how much surface it covers. Instead of thinking of this in terms of the outside edge, we're thinking about what it would cover up. And so a great thing to think about here is carpet. If you were going to put a carpet on something, that's how we're seeing the area of something. The units we would have here would be a little different. We would have square inches, square feet, square yards, square centimeters, square meters. And the reason for this is now we have two dimensions. Now we have length and width. And so we have two dimensions that we're dealing with. So our units reflect that by having square units. Basically, how many square inches would fit in here? How many square feet would fit in here? How many square yards would fit in there is what we're talking about when we're talking about area. Okay. Perimeter and area. Let's look at a rectangle first. Let's say that this particular rectangle happens to be 3 feet long and 2 feet wide. If we wanted to find the perimeter of this rectangle, there's two different ways we could go about it. One way is to just sort of imagine ourselves standing in a corner and walking all the way around and adding up, well, how much would it take for me to walk all the way around this figure? Well, if I was going to walk all the way around this figure, I would have, let's see, 3 feet on top, because it's the same as the bottom, 2 feet on the left, because it's the same as the right, and let's see, that would be 3 plus 2 plus 3 plus 2, which, let's see, that's 5 and 5, that's 10 feet would be our perimeter. That's a perfectly reasonable way to go about getting the perimeter. Honestly, that's the way we're going to find the perimeter with most figures we look at, is imagine ourselves walking all the way around the exterior of the shape. If you like having a formula, you can use a formula for the perimeter of a rectangle. It would be, well, we have the length twice, so 2 times the length, and then we have the width twice, so we can add on there 2 times the width. If you want a formula for the perimeter of a rectangle, it's here, but honestly, I think for the most part, just imagining yourself walking around the figure and adding up all the sides is very convenient, because that's what we're going to do most of the time with other types of shapes. Now let's talk about the area here. If it's 3 feet long, then I could cut that up into pieces that are each 1 foot long. Here's 1, 2, 3 feet long, and it's 2 feet wide. So I could cut that so that there's 1 foot, 2 feet. And area was about how much space this covers. So as I look at that, if each one of these is a square foot, 1 foot by 1 foot, that's how we've drawn it, 1 foot by 1 foot, how many square feet are inside this rectangle? How many of those squares are in there? Perfect, Brianna. 6. Thanks, Jennifer. So the area of this, sure enough, is 6 square feet. Now, what I want from you is a shortcut, because we don't want to have to chop up every rectangle that we draw to see how many squares are in there and count them up. Instead, there's got to be a shortcut here. My length was 3, my width was 2, my area was 6 square feet. What's the shortcut? Length times width, 2 feet times 3 feet. Perfect, Nadine said, Sunshine Jennifer, you're exactly right. The area of a rectangle is just going to be length times width. That formula we're going to use. Formula for perimeter, kind of optional because you could just add up all the sides. This formula we're definitely going to use when we want the area of a rectangle. Let me know if you have any questions there before I have you try that. Okay. I want you to find the perimeter and area of that rectangle. I'll set up a poll for it. So perimeter is listed first, area is listed second. Find the perimeter and the area of this rectangle. We'll get another 15 seconds, and then we'll talk through this together. All right, let's see how this one went. Unanimous. Fantastic. That's what I was hoping for, and that's what we got. Okay, terrific. We'll go ahead and take a look just to make sure, but and if you have questions, make sure you ask them, but I think we're probably in really good shape here. So what we have is we're after the perimeter. We're after the perimeter, which is the distance around the figure. So I'm going to imagine myself standing here in this corner and walking around it, and it'll be 13 and 7. And another 13 and another 7. So 13 plus 7 plus 13 plus 7. Now I can kind of see that's 20 and 20. So the perimeter here is going to be 40. I don't have units, so I don't know if it's inches or feet or miles, but it's 40. And then for the area, we're just going to do length times width, which here is 13 times 7, which is 91. Again, I don't have units, so I don't know if it's square inches, square feet, square meters. I don't know, but I know that it's 91. Feel free to let me know if you have questions, but the poll was unanimously correct, so I think we're in pretty good shape. All right. Now we want the perimeter and area of a parallelogram. First thing that's really good news is perimeter is going to be the same as it was before. We're going to walk around this figure and add up all 4 sides. That's how we're going to find the perimeter of this parallelogram. Now for area, let's see. First glance, you might think, well, length times width. But the problem is with this diagonal line right here, that's going to goof things up a bit. So we're not going to do length times width. Instead, when we look at a parallelogram, what I want you to do is imagine that I am going to take a saw to this parallelogram and I'm going to cut this thing right here off. I'm going to cut that triangle off. And I'm going to pick that triangle up and move it, and I'm going to put it over here. And it fits exactly right in there. And so this new shape that I have, this new shape that I made that has the same area as the shape that I started with is a rectangle. So there's definitely a relationship here with length times width, but I can't really use length times width because, these are the sides of the parallelogram and I'm not using those. Instead, what I'm going to do is as I imagine that rectangle being the same as this parallelogram, I'm going to say, instead of a length, I'm going to call this a base. And then when I made a rectangle in here, it was a vertical line from top to bottom. A vertical line that went from the bottom of this up to the top, and we're going to call that the height. And if I do the base of this figure multiplied by the height of this figure, that's how we'll find the area of this figure. Because what we're doing there is we're finding the area of this rectangle, which is the same as the area of the parallelogram we've been given. You can kind of imagine that rectangle, and you kind of put nails in these two corners, but the top can move, and you just sort of push the top over, and it ends up here. And now we have a parallelogram with the exact same area as the rectangle that we drew in. All this to say, when we want the area of a parallelogram, our formula is going to be base times height. Just make sure that your height is your vertical distance from the base up to the top. So that's going to be our formula for a parallelogram. Let me know if you have questions before I have you try one where you find the perimeter and area. All right, here it goes. There's a parallelogram. It's got some measurements on it. I want you to find the perimeter and the area of that parallelogram. If you get an answer that's not one of the ones shown, pick the one closest to yours. And if when we get close to the end, if you need more time, just let us know. We'll go another 20 seconds on this and then talk through it. All right, let's see how we did on this one. Not unanimous, but close. Strong agreement. All right, let's take a look and we'll make sure we dispel anything. There's definitely a couple of possibilities for errors to happen here. So we'll look at this through a lens of make sure you don't make these possible mistakes. That's how we'll take a look at this one. So the first thing we want to find is perimeter. So for the perimeter, I'm going to imagine myself standing here and walking around the figure. Now the danger here with perimeter is when you go to find the perimeter, it's really easy to want to include this 3 because, well, we were given the 3. There's got to be a reason I was given it. Well, sometimes there is and sometimes there isn't. But remember, perimeter is the distance around the outside edge of the figure. If I walk around the outside edge, I never walk on that 3. So this is going to be, well, I've got a 10 up top and I've got a 4 over here. So that's going to be 10 plus 4 plus 10 plus 4. 14 and 14, that's going to be 28. So our perimeter is going to be 28. And that was unanimous in the poll, so that's really good. Nobody wanted to include the 3. When we talk about the area, well, the area of a parallelogram is base times height. All right, well, base is the bottom down here, and height, make sure you're careful, that's the vertical distance from the top to the bottom. So our base is 10, our height is 3, and the 4 doesn't play a role here at all because we don't care about that side length. What we care about is that the base is 10, the height is 3, and so we multiply those and get an area of 30. Let me know if you have any questions on that before we look at our next shape. Okay. Now a triangle. Okay, well, we looked at that parallelogram and said, hey, if I chop off a piece of this and move it over, it would sure look like a rectangle. We're going to do something similar here with this triangle. When I look at this triangle here, I kind of see, well, wait a minute. If I drew in these two lines, that would make a parallelogram. And a parallelogram has a formula for area that is base times height. But I don't have the entire parallelogram here. The triangle I started with is just right here. Well, that's half of this parallelogram I created. And so the formula for the area of a triangle is going to be 1/2 times base times height. Because when we look at a triangle, a way to envision that is that it's half of a parallelogram. So the formula that we'll use will be 1/2 times base times height. Perimeter, same as you've used before. If we want the perimeter of this particular triangle, we would just add up those three sides. Let me know if you have questions on that before I have you try finding perimeter and area of a triangle. All right. There's a triangle, whole bunch of measurements on there. What I want you to do is find the perimeter and the area of that triangle. Be a little careful here. This is a little bit different than the other ones. Same as before, if you get one that's not there, go ahead and pick the one closest to yours. And we'll go another 15 seconds on this before we talk through it. All right, let's see how this one went. Not unanimous, but close. So that's not a bad place for us to be. We'll talk through this one. Let me know if you see something that doesn't make sense or if anything comes up that raises questions for you. So as we look at this one, we're going to need to find the perimeter and the area. Well, perimeter is, I imagine myself standing here and walking around the figure. So we'll do that. We'll imagine myself walking around the figure. And so that's going to be, let's see, my perimeter here is going to be 8 plus 18 plus 12. Let's see. It's okay to use a calculator. 8 and 18 is 26 plus 12 more is going to be 38. Again, we don't know the units here. Feet, yards, miles, kilometers. But we know it's going to be just linear feet, linear miles, linear kilometers, whatever it is. It's raised to the first power because we're just talking about walking in one direction. Well, walking around the figure. Let me say it that way. Now when we want the area of this, we just got to be careful. 1/2 times the base times the height. That's going to be the formula for the area of a triangle. So I need to identify the base. That's the bottom down here. And then the height is the vertical distance from the base to the top. And that vertical distance from the base to the top is right here. And so my base is going to be 18 and my height is going to be the 5. And when we go to find the area, that's 1/2 times 18 times 5. And multiplying these together, you could do it with fractions, but if you want to just do 1/2 first, 1 divided by 2, that'll give you 0.5 that you can multiply by 18 and multiply by 5. And then we have 0.5 times 18 times 5. We end up with an area of 45. And we don't know if it's square feet, square yards, square miles. We know it's square something because it's area, but we weren't given the units here, so we'll just call it 45. Any questions on that one? We've done perimeter and area of rectangles, parallelograms, and triangles. All right, very good. Here's the type of problem math teachers love. A right triangle has a hypotenuse with a length of 13 feet, and one leg has a length of 12 feet. What is the area of this triangle? And your first thought here might be, well, area of a triangle. So I know the area of a triangle is 1/2 times the base times the height. Just kind of file that away. And you might do this without drawing a picture, but I never ever would. Anytime I can draw a picture, I'm going to. I'm told it's a right triangle, so I'll just kind of sketch myself a right triangle here. It may not have the right dimensions. It's just a sketch to help me get organized. It doesn't have to be perfect. It has a hypotenuse. Have to remember what that word means. That's the longest side in a right triangle. It's the one that's across from the right angle. So that's the hypotenuse, has a length of 13 feet. So this is 13 feet. And one of the legs has a length of 12 feet. I could label either one, but since 12 is pretty close to 13, I think I'll call this one down here that's pretty similar in length to the other one. I'll call that the 12. It wouldn't matter if you labeled this one the 12 and your diagram just wasn't very accurate. It's okay. This is just a sketch, just to help us understand the problem better. It doesn't have to be perfect. But I'm going to go ahead and put the 12 down there at the bottom. All right. What is the area of this triangle? Well, the area of a triangle is 1/2 times the base times the height. I know the base is 12. What I don't have is the height. How am I going to find the height? This is what makes it a math teacher's favorite type of problem. How am I going to find the height? Outstanding, Jennifer. And it may just take a little while to type this one in. There could be a whole bunch of people following behind you. If you're typing it in, you can go ahead and finish. You don't have to stop. Pythagorean theorem is exactly what we're after for how we're going to find the height of this. Because we have a right triangle, we know that leg squared plus leg squared is hypotenuse squared. And in this case, that'll be, okay, this leg I don't know. I'm going to go ahead and call it h for height, since that's what I'm going to call it when I put it in my formula. You could call it x, you could call it leg, you call it whatever you want. I'm going to go ahead and call it h. And in this particular case, then there's the leg that I don't know plus the leg that I do know, that's 12 squared, equals the hypotenuse that I know, which is 13 squared. Now I need to solve that to find the side length of that leg. And we'll have h squared plus 144 is equal to 13 squared, 169. We're trying to get h by itself, so we need to get the term that has h in it by itself. So we'll subtract 144 from both sides. These will cancel, and that'll give me h squared is equal to 25. And then I need to get h by itself. I need to make squared go away, so I'm going to square root the left and square root the right. These cancel, leaving me just h, and square root of 25 is 5. And so I just found out that that leg has a length of 5. Really easy to get sort of drawn into a problem and say, all right, I drew the triangle, I labeled the sides, I found the one I didn't know, I must be done. Hold on a minute. Go back and make sure you read the question and answer the question that's being asked. While finding the length of that leg is really important, the question is, what is the area of this triangle? So we're not done yet. We've got to now use area is 1/2 the base times the height to find the area of the triangle. And that'll be 1/2 times the base, which is 12, times the height, which I now know is 5. And then 1/2 times 12 times 5. Let's see, 1/2 times 12 would be 6 times 5. That's going to be 30. And this would be square feet. You'd just put the 30 on a quiz or an exam, but it would be 30 square feet would be the area of that triangle. Math teachers love this kind of question because you had to remember Pythagorean theorem in order to do the new thing that was finding the area of a triangle. Let me know if you have any questions on that. All right. Circles. A circle is all the points that are equidistant from a single point. Very formal way of saying that a circle is, let's see, all the points that are equidistant from a single point. So if I have this single point right here and I were to write down all the points that are the same distance away from there, then I would get this thing, because what I have then is, yeah, all the points on here are, the same distance away from that place. So that's what makes a circle. When you draw a circle, it doesn't have to be perfect. See, it's just the idea that we have a circle here, and then that distance that goes from the center to the circle. Anybody remember what that's called? If you do, that's awesome. If you don't, it's okay, but somebody probably does. The distance from the center to the circle. Excellent, Sunshine, Nadine, Brianna, that is fantastic. We're going to call that R. That is the radius of our circle. And then you probably know this since you knew radius. What if I go through the center, but all the way from one side to the other? What are we going to call that? Outstanding, Sunshine, Brianna. Very good, Nadine. I think you're probably right there with them. Yep. We're going to put a D there because that is the diameter. So a circle has a radius and it has a diameter. And those give us a lot of information about a circle. As we go through this, make sure you let me know whenever you have questions. Okay, instead of a perimeter, circles have a circumference. Okay, so we have a circle here with the center, and that circle has a radius and it has a diameter. And now we're going to talk about the idea that it doesn't have perimeter. We're not going to talk perimeter of a circle. And a reason for that is it's not made up with line segments. It's not a polygon because it's not made of line segments. We're not going to add up all the sides because it doesn't have any sides. It's just a curve. So instead of perimeter, when we talk about the distance around a circle, what we're going to use for that is circumference. So that's the distance around a circle. Interesting thing happened when the ancient Greeks, who were kind of obsessed with geometry, were studying circles. What they found was when they took the circumference and divided by the diameter, they got the same number every single time. Whether it was a little bitty circle or a big gigantic circle, it didn't matter. If they measured the circumference and then they measured the diameter, they got the same number every single time. And what that number is, I'm going to give Nadine a chance to finish because she might be way ahead of me here. But what that number is 3.1415926, and it keeps going. It never stops. It never repeats. What's that number called? And it's okay if you don't spell it right. It's very good, Sunshine, Jennifer, Summer, perfect. That number, because this was so significant to the ancient Greeks, because every time we do circumference divided by diameter, we get the exact same number. Because that was so significant, so surprising, so remarkable, the ancient Greeks gave this a name, and that name is pi. And it's pronounced, just like pi. And it looks like this. So that's the Greek letter pi, and that because this was so remarkable, they gave it a name. So where this leads us, and I'll kind of squeeze it in here, is, okay, so you're telling me circumference divided by diameter is always going to equal pi. So if I wanted a formula for circumference, what I would do is I would start there and I would say, all right, well, if I multiply this side by diameter to get that to cancel, multiply this side by diameter. So if I want a formula for circumference, it's just pi multiplied by diameter. Sure enough, that's the truth. Our formula for, well, one formula for the circumference of a circle is pi multiplied by diameter. Let me know if you have questions on where I got that from, because I want to make sure that's clear. We also know that diameter is just 2 times the radius. If we look at our picture over here, there's a radius and another radius. So diameter is really just 2 times the radius. And again, if I say anything that's confusing or doesn't make sense, you let me know. So what I can do with that then is this formula down here is great, but I'd like to have another one. And what I can do is, since diameter is 2 times the radius, I could say the circumference is pi times 2 times the radius. Because all I've said here is circumference is pi times diameter. I just wrote diameter a different way. Now that feels a little clumsy, pi times 2 times r. So instead, the way we'll write that one, just an alternate formula for circumference is 2 times pi times r. Both of these formulas can be either of these formulas can be used to find the circumference. It just depends. If you've been given the diameter, you probably want to use this one. If you've been given the radius, then you have the option of using that one. Either of those will help you find the circumference of a circle. We haven't talked about area yet. Area, just a straightforward formula. The area of a circle is pi times the radius squared. A lot of times I will kind of lean towards this formula for circumference because it uses radius. And the reason for that is our formula for area uses radius. So sort of my first thought of which formula will I use for circumference is this one, because the formula for area uses radius. So for either of those formulas, I know I'm using radius. The only thing to be careful of with the area formula is it's pi times the radius squared. Make sure you follow order of operations. Exponents happen before multiplication. So we're going to square the radius first and then multiply by pi. One last thing I want to say before we leave this one is, while it's true that pi is this non-terminating, non-repeating decimal, and you probably have a pi button on your calculator, what you're going to see in the instructions for these problems is we're going to use pi as 3.14. We're just going to use 3.14 instead of the pi button. If you use your pi button, and the reason we're going to do this is so that we all get the same thing. I don't want half of you using the pi button and half of you using 3.14. We're just all going to use 3.14. Canvas is going to expect you to use 3.14. If you use a pi button and your answer's off by a tiny little bit, you can send me an email and say, I know the instructions said use 3.14, but I use my pi button. Can I have credit? And I'm going to say yes. So just so you know, I want you to use 3.14 only because we're all going to be consistent. But if you use your pi button, it's okay. Any questions on anything there? All right. Find the circumference and the area of a circle that has a radius of 5 centimeters. And there's a little note, use pi as 3.14. So don't use a pi button, use 3.14. I'll set up a poll for this and let you try it. We'll go another 15 seconds on this and then we'll talk through it. Let's see how we did here. Unanimous. Fantastic. That's great. Okay, good. That's kind of how I expected this one to go, but it's always nice when it turns out that way. This one is really just about using the formulas for perimeter, or excuse me, for circumference and area of a circle. And our circumference, well, I could use pi times d, or I could use 2 times pi times r. Since I was given the radius, I'm going to go ahead and use 2 times pi times r. So my circumference here is going to be 2 times 3.14 times the radius, which when I multiply, 2 times 3.14 times 5 is 31.4. They would be centimeters, but our answer would just be 31.4. And then for area, and I'm really glad nobody made a mistake here, which is awesome, pi r squared. So we're going to put in pi times the radius, which is 5, squared. Order of operations tells us to square it first. So 5 times 5 is 25. And then when we multiply 25 times 31.4, or excuse me, 3.14 times 25, we get 78.5. And that's our area. And that would be centimeters squared, or square centimeters, but we just answer with the 78.5. Poll went great. Let me know if you have questions, but I'm kind of thinking we're in really good shape on circumference and area of a circle. Okay. Here's another circle-related problem. If the circumference of a circle is 28 inches, what's the area? Use pi as 3.14 and round your answer to the nearest tenth. So if the circumference is 28 inches, so, okay, well, I've got a formula for circumference that is 2 pi r, or I could say circumference is pi times d, but wait a minute, this question said, what's the area? Neither of these formulas is going to take me straight to the area. Instead, what I'm going to do is I'm going to think to myself, hey, I need the area. And the area is pi r squared. So if I want to find the area, I'm going to need the radius. So I'm going to use this formula for circumference to help me find the radius. And then after I have the radius, I'll go find the area. So this is a two-step process. I couldn't go straight there. I don't have the ability to do that. First, I have to find the radius, then I can find the area. All right, let's see. Circumference is 28, so 28 equals 2 times pi times the radius. And we just need to solve this equation. Well, I'm going to go ahead and simplify the right-hand side. 2 times 3.14, that's 6.28 times r. And now I need to make multiplication go away. So I'm going to divide by 6.28 on the right, divide by 6.28 on the left. If anything in there doesn't make sense to you or not sure why I did it, please don't be shy about asking. I don't know what 28 divided by 6.28 is. Looks like 4.4585, and that keeps going. And that's equal to my radius. Now, I'm not done yet. I'm not going to do any rounding until I get to the very end. So I'm just going to leave that number sitting there on my calculator, that 4.458598 keeps going, keeps going. I'm going to leave that sitting on my calculator and go over and do the remainder of this problem, which is that the area is equal to pi times that radius that I just found, 4.4585 squared. So the first thing I'm going to do is I'm going to leave that number on my calculator and I'm going to square it. And now I have 19.8791. When that keeps going, one more step, I need to multiply by 3.14. And now I have an area of 62.42038. And that keeps going. And now finally, at the very end, Now is my opportunity to round. I'm not going to do any rounding until I get to the very end. Now that I've made it to the end, I'm going to round my answer to the nearest 10th. So I'll find the 10th place, look one space to the right. Since that's 4 or lower, we'll round this down to 62.4. They would be square inches, but we don't have to include that part. A little bit inconvenient to keep all these decimals and not do any rounding till we get to the end, but it kind of sets up nicely that once we have that radius, that number can just stay on the calculator, because now I'm going to square it. And after I square it, I'm going to multiply it by 3.14. And then I get to a number at the end that I can round. But please don't round that during the problem. If you round that to 4.5 for a radius, your answer will definitely be off, and probably by quite a bit. So don't do any rounding till you get to the very end. Let me know if you have any questions on that before we move off of circles. Okay. Composite figures. What a composite figure is it's not a rectangle or a parallelogram or a hexagon or a trapezoid. It's just sort of a figure that we don't really have a name for. It's almost like two shapes smashed together, and that's kind of exactly what we're looking at here. I have this sort of kind of, reflected, rotated L shape here that I want to find the perimeter and the area of. If I want the perimeter and area, well, perimeter, I need to add up all these sides. I need to imagine myself standing here and walking around it. So I'm going to need to know how long this side right here is. Looking at the horizontal lines in this figure, can any of you tell me the length of that line right there? And the next, outstanding, wow. And how did you get it? What did you do to get that 8? Perfect. Boy, all three of you right there, 10 minus 2. If I look at the horizontal lines, all the way from left to right is 10. This much of it is 2. And that 2 could be here. It'd be the same distance, which means to finish that off, to be the rest of it, I need that horizontal line up there to have a length of 8. And sure enough, it does. Using similar but not exactly the same logic, how about this side length right here? How long is that one? Brianna, 7, not quite as sure. Summer and Jennifer, Shelby, perfect. How'd you get the 7? Three plus 4, 4 plus 3, outstanding. Exactly right. That's exactly how we want to go about that one. We want to say, well, if I have this vertical line here that's 3, I can imagine it being here. And I have this vertical line that's 4, I can imagine it being here. And when I put those together, that's a vertical distance of 7. So sure enough, that side length is 7. And now, because I know all the side lengths, I can find the perimeter. It'll be, imagine myself up there in that top left corner. You don't have to start there. You can start anywhere. Just don't make sure you don't miss any. It's 2 plus 3 plus 8 plus 4 plus 10 plus 7. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That doesn't guarantee that I have all the correct numbers written down, but at least I have the correct number of numbers written down. I probably didn't make a mistake in writing them down, so I feel pretty good about where this is, and we'll go ahead and add those together. So let's see. 2 plus 3 plus 8 plus 4 plus 10 plus 7 is 34. I don't know what the units are here, so we'll just call it 34. Let me know if you have any questions on how we got there before we do our next step, which is to look for the area. I have a formula for the area of a rectangle, the area of a parallelogram, the area of a triangle, but I don't have a formula for the area of an L shape. So I'm not going to be able to do like, what's the formula of an L shape? Instead, what I'm going to do is I'm going to cut this into smaller pieces. I'm going to create a rectangle here, and then I'm going to create another rectangle down here. I'm going to find the area of those 2 rectangles and add them together. one thing I do want to say before I go too far down that road is, if you look at this and said, well, wait a minute, I wanted a rectangle here and the other rectangle to be here, that's perfectly fine. You'll get the same answer either way. Just make sure you're careful when you put your side lengths in. Well, heck, I'll go ahead and do it that second way. This is less common, so maybe this is a fun reason to do it. So I have those two rectangles that I want to find the area of each, and then I'll add them together. So we'll start out with the red rectangle. And when I look at that red rectangle, what I can see over there is I have a width of 2 and a height of 7. Be careful. This 3 is staring at you, but that 3 is not the height of that rectangle that I drew. That rectangle is 7 by 2. So when I multiply, I get an area of 14 for that rectangle. Now with the purple rectangle, okay, it's 4 by something. Be careful. There's this 10 staring right at us, begging us to use it, but no. This rectangle is 4 by 8. The way that I drew that rectangle, the side lengths are 8 and 4. So I'll multiply those and get 32. And so the total area of this is going to be 14 plus 32, which is what? 46 square somethings. And that's the total area. If you drew your rectangles the other way and you had one rectangle that had 40 and one rectangle that had 6, you'd end up with the exact same answer. Let me know if you have questions on this before I have you try one. All right, here you go. This is kind of a U shape. What I want you to do is find the perimeter and the area of that figure. I'll set up a poll for it and I'll let you try it. If you get an answer that's not one of the ones shown, pick the one closest to yours. And I'll give you some time on this because I know that, these take a little bit of processing time. So we don't have to be in a hurry. And just to make sure the process is comfortable here, we've got to find those missing side lengths first. Once we know those, then we can go about the work of finding perimeter. Then we'll cut it up, and you could cut it up a couple different ways, and find the area of each little piece, combine those to find the area of the whole thing. We'll go another 15 seconds, then we'll talk about it. All right, let's take a look. Unanimous, really good. I don't know that these are simple, and it went extremely well. That's terrific, very good. Well, we're gonna talk through it just to make sure we're all comfortable with everything here. First thing we've got to do is find the missing side lengths, and I've got a vertical length of 7 on the left-hand side, and this is exactly the same, so that's going to be 7 also. And then horizontally, I've got 16 all the way across. I've got a 4, a something, and a 1. So 4 plus something plus 1 is going to make 16. And so let's see, that's 5 plus something is going to be 16. So that something must be 11. And you could go about that a different way. You could certainly do, well, if I do 16 minus 1 minus 4, that will get you to 11 also. That's really the same thing that we just did. We wind up with a length of 11. And so for our perimeter, I'm going to imagine myself starting here in the top left and walking around. And that's 4 plus 3 plus 11 plus 1 plus 7 plus 16 plus 7. Then we'll add all those together. 4 plus 3 plus 11 plus 1 plus 7 plus 16 plus 7. I did. I missed one. Y'all let me get away with it. There's a 3 right here that I didn't include. Don't forget about this 3 right here. We need that. So there's a 3 right there that I'm going to tack it here on the end. But 4 plus 3 plus 11 plus 3 plus 1 plus 7 plus 16 plus 7. Sorry about missing that 3 right there. Adding all those together, we get a perimeter of 52. My guess is you are also comfortable with it, that you're like, yeah, you missed the 3, but that's fine. I know it's there, and that's okay too. Now for the area. Last time we cut it up with a tall rectangle on the end, so let's do a long rectangle across the bottom this time, and then we'll throw in a little rectangle here and a little rectangle here. Be careful when you identify your side lengths. This is 4 by 3, so that's going to have an area of 12. Yes, there's a 7 staring at us, but a 7 is not one of the side lengths, so we don't use it. Over here, it's 1 by 3, so that rectangle has an area of 3. Yes, there's a 7 right here, but that's not our side length, so we didn't use it. And then when we talk about the orange rectangle at the bottom, that's the whole length of 16. And how tall is it? Well, if all the way from top to bottom is 7, and this much right here is 3, then that piece must be 4. And so that big giant rectangle that we have there at the bottom has a length of 16 and a width of 4, so its area is 64. And then adding those together to get the total area, we have 12 plus 3 plus 64. 12 plus 3 plus 64, that's 79 square somethings. The poll is unanimous. I don't think those are easy questions, so that's fantastic. If you have any questions on it, let me know before we look at a couple more perimeter area type questions. All right, here's one that I always like to kind of see how it goes. Find the area of the shaded region in the figure below. So what we've got here is a rectangle. You can imagine like this part is a swimming pool, and then there's a walkway around the swimming pool, and we need to know how much concrete to use if we're going to make a swimming pool. So we need the area of just this walkway around here. There's a couple ways to go about this. One way is to be, well, I guess I could figure out the dimensions of this rectangle over here, and this rectangle here, and this rectangle here, and this rectangle here, and add them all together. And that would work. Anybody have something simpler? And basically, just sort of as a general statement, you know, how'd you do it? And yes, Summer, it's 24. So what you're thinking is exactly right. Excellent, Sunshine. I like it. And you can do it with the numbers the way Sunshine did, or you can do it with words if you want to. I'm all right. Let's see. I like it. So find the area of the larger rectangle and the area of the smaller. Subtract the smaller from the larger. Outstanding, Jennifer. That is perfect. So if I find the area of this big giant rectangle here, which is what Sunshine and Summer were both doing with the 9 times 5, that big giant rectangle would have an area of 45. 9 times 5, that big giant rectangle has an area of 45. But then if I want to subtract off the area of the inside rectangle, that would leave me with just the blue part. And the area of the inside rectangle, the area of that rectangle that's in there, is just 7 times 3, or 21. So if I subtract that 21 off of there, I'm left with 24 for the area of just the shaded part. Outstanding. So if we do the big one, subtract the one that's inside of it, we'll get the area of the blue part that surrounds it. Really good. This one we're going to try. We'll see how it goes. What I want you to do is round it to the nearest hundredth, find the area of that Pac-Man looking shape right there. It's not a circle. It has a lot to do with a circle. What we see there in that picture is, you can imagine this being cut into 4 pieces. What we have here is 3/4 of a circle. That's all I'm going to say. I'm going to set up a poll for this one and see how it goes. What is the area of that Pac-Man looking shape? The key to a problem like this is to not overthink it. It's just exactly what your instinct tells you. That's the right thing to do. Um, and if you follow your own logic, you'll get to the right place on this one. We'll go another, let's go 20 more seconds, and then we'll talk about it. If you need more time, let me know. If you get an answer that's not there, pick the one that's closest to yours. Okay, not unanimous, but close. That's a good thing. All right, let's take a look, and you let me know if there's anything that you want to ask about. So let's see. What I'm going to do first here with this, because this sure does look like a circle, I'm just going to pretend that it's an entire circle. And I can see here that the radius would be 4. So if I had a circle with a radius of 4 and I wanted the area of that, I would just say, well, the area would be pi r squared, which would be 3.14 times the radius, which is 4 squared, which would be 3.14 times 16, which is 50.24. So if I had an entire circle, the area would be 50.24. But I don't have an entire circle. Instead, what I have here is 3/4 of a circle. So what I'm going to do then is I'm going to find 3/4 of this area down here. That'll be the area of the figure I was given. So 3/4 of is a word that lets us know to multiply 50.24. And 3/4, you can just do 3 divided by 4, get 0.75 that will multiply by 50.24. And when we do that, we get 37.68. And so the area of that figure, rounded to the nearest hundredth that already is 37.68. Let me know if you have questions on that. Main key step there is we have to pretend that it's an entire circle first and then go from there to finding the area of what we've been given. Okay. Just some homework tips before I turn you loose today. In number 12, a square fence becomes a circular fence. The way the question reads can be a little bit twisty. It makes perfect sense to me because I've read it 100 times. But the first time you read it, you might be like, what? But basically, you have an existing square fence. It's going to be torn down and built into a circular fence. So that's the idea in number 12. And then a hint for number 13 is a Pythagorean theorem situation with x squared plus x squared equals 12 squared. And that's just sort of a hint to help you out with 13.